Hello everyone and welcome to today's presentation. In this video, we'll be discussing a predictive model for income classification. Our main objective is to develop a model that can accurately classify individuals based on whether their income exceeds a specified threshold of $50,000. Let's start by taking a look at the dataset we'll be working with. It contains a wide range of demographic, socioeconomic, and employment related features. These features provide valuable insights into the factors that influence income levels. Our task is to predict whether an individual's income exceeds $50,000 or not. Now let's discuss the approach we have taken to build our predictive model. We began by pre-processing the dataset, which involved tasks such as handling missing values, encoding categorical variables, and scaling numerical features. Next, we set a machine learning algorithm and trained the model on the pre-processed data. In data analysis, outliers are data points that significantly differ from other observations in a dataset. Outliers can distort statistical analysis and machine learning models, leading to inaccurate results. Linearization is a technique used to handle outliers by replacing extreme values with less extreme values, typically the nearest non-outlying value. If you see, for handling missing data, there are so many values with a question mark. Initially, I replaced with null. Then, for object data type, I replaced with mode. For non-object data type, I replaced with median. For outliers, as I said, I used linearization technique to handle outliers. I have not removed outliers or missing values because as there are so many missing values and outliers in the dataset. And I performed some EDA for income status by gender and age distribution and education levels. If you see these plots, the persons with high school graduates are getting high salaries. Then coming to the code, first I have loaded all the modules and all the necessary libraries. Then I loaded train set and test set. Then I replaced question mark with null values. It's the code for to load train and test data set. Replaced question mark with null values. See, there are so many null values. So I replaced with mode and median. For object data type, I replaced with mode. For non-object data type, I replaced with median. Then I checked whether there are null values present or not. No, there are two null values. Then with the use of scalar modal selection, I use train test split to split the data. And I imported label encoding to convert categorical variables and random forest classifier. As of now, I load the random classifier. For EDA, I have used Seaborn and Matplotlib. This is the age distribution plot. This is the income status by gender. That's the education level graph. And as I said, There are so many outliers, so I used linearization technique. This is one of the technique to handle outliers. Without removing, we can use linearization technique. And for dealing categorical variables, I have used a one hot encoding. This is the code. And label encoding, because we have to pass this data to machine learning model. So we have to convert categorical variables. After that, I have identified relevant features that contribute to accurate predictions by using feature importance for random forest classifier. This code will give top 10 features which contribute to income predictions. These are the top 10 features. And I told about winsorization process. For each variable, winsorization function. Let's discuss about winsorization. This is the code. The winsorization function takes two main parameters, the variable to be winsorized and the limits parameter. See, I have used these variables. The limits parameter will specify the proportion of extreme values to replace with less extreme values. Here we set the limits to 0.05, 0.05, meaning that we are replacing the bottom and top 5% of values with less extreme values. After applying winsorization, we create new variables in our dataset with the suffix underscore winsorized, indicating thus these variables have been winsorized. I have plotted the day figure after winsorization. We have seen there are no outliers after winsorization. See, winsorization is a useful technique for handling outliers in a dataset if there are so many outliers. By replacing extreme values with less extreme values, winsorization helps improving the robustness of statistical analysis and machine learning models. Now coming to feature importance. Random forest is an ensemble learning technique that builds multiple decision trees and combines their predictions. One advantage of random forest is its ability to provide insight to the feature importance. That's why I have taken random forest classifier. In random forest classifier, feature importance is calculated based on average decrease in impurity. For example, Gini impurity or entropy. When a feature is used for splitting across all decision trees in the forest, features that lead to the greatest reduction in impurity are considered more important, as they contribute more to the predictive power of the model. Feature importance, then high feature importance indicates strong predictive power, while low feature importance suggests weaker predictive relevance. Then we come for imbalance technique, undersampling technique. Undersampling is a technique used to address class imbalance in classification problems, where one class, usually the minority class, is underrepresented in the dataset. Undersampling involves randomly removing instances from the majority classes to achieve more balanced class distribution. By reducing the sizes of the majority class, undersampling aims to improve the performance of the ML models. Common undersampling techniques are random undersampling, near-miss algorithm, edited nearest neighbors. I have used random undersampling. This is the code. After random undersampling, see the data is balanced. Then I use train test slate. I have extracted a target variable which is income above limit, below limit is the target variable. Then I have split the data. I used RF classifier. And evaluation matrix. This is the evaluation matrix. We got accuracy as 0.93%, precision as 96%, recall 93%, F1 score 95%. And these are the top 10 features. Then I tried to implement the Flask model. For this, I have imported this model using pickle library by using top 10 features, and I have built this app.py for Flask. For this, I have imported Flask modules. Method for Flask, these are for look and feel, like index and result page, etc. In running this Flask application, let's see the output. It's taking time. Mistakes we have seen already. Here's the sample output. I have entered these values. Then if I click predict, you'll get this output. That means if we get true as the output, that means our prediction is above threshold values, else it is below threshold values. If I have no space in my system, then it will take so much time. I got this. Video exact inputs.